My name is Nakamutedi, Computer Science here at Tomago University, and I'm going to take you through part of our pitching under the topic. I'll start with personal legislation for fraudulent gas and power consumption detection, XD fraud X4 short. So some of the keywords you have in here. You have anomaly detection, which is concerned with detecting unusual occurrences in data. Then deep learning, which is concerned with the use of neural networks to solve complex problems. And have fraud detection, which is detecting these fraud activities or unusual occurrences we're talking about. Then for machine learning, to deal with teaching machines how to do tasks without explicitly telling them how to do it. Then with multi-started learning, we make use of multiple techniques or algorithms to solve problems. Then for power fraud, we mean theft of these resources that we are talking about, that is power and gas. Then also have personal legislation, which is to do with getting knowledge from a teacher model and then distilling it to a student model and applying sparsity to obtain a lightweight model. So the problem we are basically addressing here is fraud in gas and power consumption. So we realize that fraudulent activities such as meter tampering, illegal connections, also energy theft lead to financial losses to these companies that provide these resources. Then we also realize that traditional fraud detection methods struggle with highly balanced data because in most cases this data since the data captured, there are more non-fraud cases than fraud cases captured. So our goal is to develop an intelligent detection system that minimizes false negatives while maintaining high precision. So, and some of the computational problems also faced were data imbalance, temporary dependencies, then scalability issues, also sparsity of noisy data. Then some of our project objectives, we have wanted to develop started personal legislation model to improve fraud detection accuracy in gas and power consumption, and also wanted to implement and evaluate techniques of handling imbalanced data, and in which we used undersampling and oversampling techniques of near miss and spot. Then we also wanted to assess the computational efficiency of the proposed model and then the traditional way of detecting fraud, gas and power. So our solution, our approach used multi-started personal legislation together with machine learning and deep learning techniques to detect fraudulent activities in gas and power. Then our method, we distilled knowledge from a high-capacity teacher model. We used 3 teacher models in one, and then we also distill the knowledge into a lightweight student model, which is a neural network. So this is how the architecture of how all this happens. We have raw data, then we do data processing, we obtain clean data, and then use that data to do model training. We train 3 feature models initially. This is random forest, XGBoost, and light GBM, and then apply assembly learning to it and obtain a voting classifier model. And then after that, we do knowledge distillation to an artificial neural network, after which we apply sparsity to obtain a lightweight model, which is prediction. So the data used, so we used the public data sets and it was sourced from Stage. It included events, past events and billing information. And then it had 20 features. It had 3,298,909 entries, and it was between 2005 and 2019. So the data set included different features, for example, the client ID, the client, the invoice data, and the client data that was to detect, to track the energy consumption patterns between those different years. So we performed data processing, checked for missing values. We removed the outliers and selected some features. We also did categorical encoding to the variables, and we're able to perform and to obtain a balanced data set on which we used to train the models. We used oversampling and undersampling techniques, that was the near miss and the SMOT techniques, to obtain balanced data. So this visualization shows the distribution of the fraud and non-fraud cases, where we see the non-fraud cases outweighing the fraud cases. That is the imbalance of data that we talk well. Then these visualizations also describe the data set where we did a distribution by the district or region. Then we did by average consumption by tariff, and also we're able to see the consumption, the average number of fraud cases with electricity and gas separately. Then the model we came up with, we used 3 teacher models. That is a random forest model and XGBoost and light GBM, combine them using a voting classifier. And then we chose these models because they can very well handle complex data, they can handle imbalanced data, and also provide robust predictions. So the voting classifier, it was aggregated, and we got soft labels from it, which we instilled to the student artificial neural network. And then after it learned, then we applied sparsity to it, and then we're able to obtain a lightweight model. So this the first visualization shows the 10 models we initially trained and evaluated, and with before sparsity, and then applied sparsity to all models. So we're able to see that some models like XGBoost are maintaining their performance, others are improving. Then there are those that declined in performance. For example, the decision trees and support vector machines, and among others. So the system architecture is that we had raw data, then cleaned it through data processing, where we handled missing values, we did the balancing, and then we used that clean data to train these 3 models we've talked about, then evaluated them, applied dissembled learning to obtain a classifier, voting classifier model, from which we got soft labels, distilled them to an artificial neural network, and then applied sparsity, obtaining a sparse neural network, which we deployed through an API to our web application, and then we're able to do predictions. We even tested it and saw it working well. So some of the implementations we did, implementation details as we implemented, we basically and primarily use Python as our language, and then we use platforms like Google Colab, Kaggle, Visual Studio Code to come up with these codes that we use to train and evaluate the models. And some of the libraries and frameworks we were able to import that were necessary for our project were Skitland, TensorFlow, XGBoost, like GBM, others, Navi, JogLib, Sharp, and Lime for explainable AI. Then the results we obtained after training our progressive model is that we initially trained the individual teacher models, then used the voting classifier to obtain a voting classifier model, and then distilled knowledge to an artificial neural network, and we applied sparsity. So we saw sparsity improving, reducing the weight of the model, but then maintaining its well performance, like improving its performance. So the model is able to perform so well. So we looked at the accuracy, the precision for both fraud and non-fraud, the recall, and also the F1 score metrics, like illustrated in the table. Then we're able to come up with some visualizations, that is the confusion matrix and the ROC curves for these different models. And from there, we realized that the models are performing well.
My name is Namata Manesha, starting from where my colleagues stopped. So looking at the impact and the relevance of our solution. So it has a local and global relevance. So looking at Uganda in specific, here we enhance fraud detection in Uganda's evolving utility sector. It is known and it has been like written about in different news articles, how much fraudulent behavior in electricity consumption there is in Uganda. So our solution enhances, it supports national initiatives in modernizing the energy infrastructure and also preventing fraud. And in a global context, it is applicable to utility providers worldwide facing fraud operation inefficiencies. It is also a very scalable solution that adapts to diverse markets. And the fact that we are building on top and modifying and modernizing the existing solutions, it is one good solution. So our targetees and the beneficiaries are the utility companies and service providers like UEBCL, the Uganda Electricity Distribution Company, and the Uganda Electricity Transmission Company. Then we also plan to work with government agencies and regulators focused on energy efficiency and fraud prevention, and also private sector investors and technology partners in the energy market. SDG alignment, we align well with SDG 7, which is affordable and clean energy. Our solution ensures there's reliable and efficient energy distribution, and also SDG 9, which is industry, innovation, and infrastructure. So our solution drives innovation through advanced machine learning techniques, the multi-strategy learning, sparse learning, knowledge distillation. It fosters innovation and infrastructure that way. And then there's also responsible consumption and production. Here, our solution promotes sustainable use of resources, intellectual property, and innovation. So our core innovation is a hybrid pipeline which combines sparse learning and ensemble models and knowledge distillation as shown in this vision. So it is a hybrid pipeline which integrates ensemble learning, that is the more strategy learning, and sparse learning knowledge distillation, which offers customized soft label generation, model compression techniques, which are all optimized for fraud detection. And then for intellectual property, we have a unique workflow which is suitable for patenting, copyright protection for code and documentation, and also proprietary methods kept as trade secrets. So we have a unique workflow. This is suitable for patenting. And also we have copyright protection for code and documentation. We also have proprietary methods kept as trade secrets. So how we plan to monetize and scale our products. So we have our product offering. We offer our product as a cloud-based software as a service product or API for real-time fraud detection in Uganda and East Africa at large. It is customized on-premise deployment. It has the ability to be customized on-premise deployment for low connectivity utilities. And also for the market opportunity, there is rapid modernization in the local market. So we can also expand into the East African market. We can focus on multimodal expansion for electricity and gas consumption. And then we also utilize licensing for the revenue model. For the revenue model, we utilize subscription licensing, like we do get money for every subscription, which is either monthly or annually, depending. And also we offer consultation services, and we integrate services that are also available for revenue. So some of the weaknesses of our system, because we also did a SWOT analysis and to identify the weaknesses, it is highly dependent on quality data and continuous updates, because like fraud methods, people who with fraudulent consumption activities keep on evolving. Like when you come up with a solution, they also try to come up with a new way so that they will bypass your solution. So we also need to continuously update our model, and we also need quality data. And some of the opportunities for us, we have local partnerships and multimodal expansion for the electricity and gas sector. And threats, there is competition, of course. So many other people are also coming up with similar solutions, and regulatory shift. There's always a shift. And so for scaling and growth, we do plan on customer acquisitions by conducting pilot projects with major utilities and strategic local partnerships, e.g. Hive and Collab. So for scalability, we want to do a modular design and multidisciplinary team, a strong IP portfolio which makes us ready for funding. Those are the contributions. No matter how I worked on the data pre-processing. I also did the data cleaning. Data pre-processing involves like because our data set was highly imbalanced. In the pre-processing steps, I did I worked to like try to balance the data set. I undersampled the major class and oversampled the minor class. And when my colleague Teddy did the training for the different models, I came in to do the optimization and work on the advanced machine learning techniques. Those what we use to optimize our model and make it different, strategy learning, knowledge distillation, and sparse learning. And I also worked on the deployment. Then my friend worked on the data collection and merging the data sets using a common field. She also trained all our models and she worked on that. She worked with the technical writing. And so for the system demo, so this is what our system looks like. This is the hosted version. We haven't really built a beautiful user interface. This is what we have for now, but we plan to do that later. So when you click on this link, Fraud Detection Pro on render.com, it brings you to this form. And here you enter the features which are the district of the person, the tariff type, the consumption level, what are they consuming, is it electricity or gas? When you enter those features, numerically and they are comma separated, like for example here in this picture, and then you click on predict, we return here a prediction 0. So 0 shows this person is good, is not involved in fraudulent activities. And if it returns a 1, we see that person is fraudulent for consumer, that person is involved in fraudulent consumption. So this is what we have for now. Of course, yeah, we work on improving the interface. And lessons learned and challenges. We did have some precision recall trade-offs, like balancing the false positives with the false negatives, and data quality and imbalance. I think this was the major issue. We had missing values, noise, limited real-world fraud cases. Since this is like security, this is cyber data. We had few cases of fraud and very many normal consumption cases. That was a major deal. And generalizability. So our model requires it required frequent model retraining for different regions and evolving fraud tactics. So the lessons, so some of the major lessons learned are the importance of data. So clean and comprehensive and balanced data sets are crucial for accurate fraud detection. This is so true because the very first models we had, because we were new to machine learning, we didn't quite know how to work with imbalanced data sets and all those things. So the very first models we had were highly biased. They had a higher precision for the minority class and a very low precision for the majority class. They had a higher precision for the majority class and a low precision for the minority class, and that was very bad because you cannot deploy such a model, you cannot put it into business because you are bound to get losses. So we had to work on like cleaning the data, pre-processing it, and balancing it. So it is very important for you to have clean and balanced data sets for fraud detection so that you do not build biased models. And then model efficiency. Here we notice that knowledge distillation reduces the computational overhead and it requires continuous updates. And for adaptability and maintenance, there's regular monitoring is required and retraining are required to tackle emerging fraud patterns. And also an interdisciplinary approach where you collaborate between data scientists, domain experts, and engineers to ensure effective and efficient deployment. So some of the things we plan to do in the future, we want to enhance imbalance mitigation. So we want to integrate contrastive learning or dynamic loss weighting here to continuously boost the minority class recall. And we want to refine our model compression. We want to address the trade-off between the student model size and performance. And real-time adaptability, we want to implement online learning mechanisms for our model so that it continuously learns evolving fraud patterns. It's like want to do a continuous integration, continuous deployment. And I want to do a border validation, want to extend to multimodal utility, I want to extend to multimodal utility data for better generalizability. So in conclusion, some of our achievements here, we had a higher recall for class 1, which was 0.72. We reduced features with sparse learning and sorry, we reduced features with sparse learning, 60% of the features were reduced, but and not affecting the model's performance, and we cut the size here in knowledge distillation by 40%, but still not affecting its performance. And there was faster inference and 30% faster inference, which is really, really good. And so from here, we noticed that hybrid learning strategies offer superior fraud detection performance, and it paves way for more accurate, efficient, and adaptable systems. So we combine traditional machine learning and deep learning through the multi-strategy approach, the ensemble methods, sparse learning, and knowledge distillation. Thank you so much.